Hello everyone. Today we are here to present our problem statement in Smart India Hackathon 2024 given by National Disaster Response Force. Our problem statement ID is 1566 under the hardware category, theme disaster management. Our problem statement title is Enhancing Body Detection in CSSR Operations Using Advanced Technology. Our team ID is 17537 and our team name is the Life Guardians. We are from Prestige Institute of Engineering, Management and Research, Indore. Welcome to our presentation on the ADU 3000, an autonomous detection unit designed for CSSR operations. By utilizing GPR, thermal imaging and ion mobility spectrometry, IMS, our drone assists in detecting survivors and deceased victims in disaster recovery. The current method tracks the body movements and heartbeats to rescue the living organisms. Rescue efforts rely on methods like canine searches and acoustic sensing. These approaches have limitations, often struggling to accurately locate victims, especially in complex collapse structures. Now, the ADU 3000 provides a faster, more reliable solution by integrating advanced sensor to pinpoint victims more precisely. Our proposed solution is a drone equipped with three key technologies: GPR for underground scanning, thermal imaging to detect the heat signatures, and IMS for detecting the chemical compounds. IMS is a standout feature as it identifies ion patterns in the air, making distinguishing between the living individuals and the deceased victims easier. This multi-sensor approach allows rescue teams to gather real-time critical data more accurately. This is the CAD model which we have generated for a proposed solution, that is the ADU 3000. Basically, in this, the UAV will be equipped with the three sensors. The very first would be the GPR technology for underground scanning. The second one would be the thermal imaging, which would be using the heat signatures to track the living organism. And the third sensor which would be using would be the ion mobility spectrometry, IMS, which can just sense the volatile compounds or the gases that are released from the deceased bodies, and we can get a track of the dead bodies which are under the debris, which are trapped under the debris. And this is how our whole UV would be equipped with these sensors. Now, moving towards the technical approach, the ADU 3000 uses the state-of-art hardware like the ion mobility spectrometry, GPR and thermal imaging, all powered by lithium polymer batteries. Software tools include the Python, C++, ROS and GIS for drone navigation and data visualization. The IMS sensor stands out by detecting specific gases related to decomposition, giving rescue teams more vital information. Meanwhile, the GPR scans deep into the debris, ensuring that no area goes unchecked. Now that we have outlined the solutions and key features of our project, let's take a closer look at how our project basically works, the methodology or the process of implementation. So first we'll be assessing the disaster site. After that we'll be planning the path for our UAV, and now at this third stage we'll be deploying GPR with our UAV so we can detect the voids or the uncertainties under the debris or the ground. And after that we'll be sending the rescue teams to the pinpoint locations that we have got from the GPR for removing the upper layer of the debris, so that it would be easier for the thermal imaging device and IMS to just combine together and search for the living and dead organisms. After the rescue teams removes the debris, the thermal imaging device would be sent for the live body detection with the help of the heat signatures. Along with that, the IMS activation would also be done for the detection of the deceased body, and we'll be getting the pinpoint locations, and that would be marked with some points or the red dots on the map of that certain area, and that all would be the real-time data processing that would be done. And with the help of that, we can just do the retrieval of the deceased body or the living organisms and can save more lives, and that would how our whole proposed solution would be working. Now moving towards the feasibility and viability of our proposed solution. So our solution is operationally feasible and environmentally friendly, and cost effective. It requires minimal training for rescue teams and integrates easily with existing systems. And the potential risk that could be generated from our proposed solution would be the sensor limitations, the UAV constraints, the data processing, operational challenges. So all these potential challenges could be solved with the multi-sensor integration. We can optimize the payloads as we would be using the detachable sensors. First we would be sending the GPR and then the other sensors, and we can also optimize the algorithm, and a comprehensive training would be given to the rescue teams for just reducing the operational challenges, and safety protocols of that area and the norms would be followed for the regulatory and safety issues. Now coming towards the impacts and the benefits, so our ADU 3000 is very minimal, provides very minimal damage to the environment and does not emit any kind of hazardous substance, making it very environmental friendly, and potential for integration with renewable energy sources also. And if we come towards the economical benefits, so it is cost saving. We'll be using the things which are very cost friendly and environmental friendly, so that's the benefit. And it is potential for job creation, as engineers would be needed to construct the ADU and the trainings would also be provided, so that also create job opportunities for the people, and increase funding and investment opportunities from the government itself, because as it can save more lives and in less time and less effort. Coming upon the technological benefits, so enhance sensor capabilities by integrations and real-time data processing and transmission, and it reduces the human error by enhancing overall system reliability. And if we come upon the potential impact on the target audience, so our ADU 3000 benefits are numerous. Rescue teams will have the tools to locate victims faster and more accurately, leading to a higher survival rates in disaster zones. And for communities affected by disaster, the ADU 3000 represents hope that will help arrive swiftly and efficiently. And I would just say that the ADU 3000 offers a groundbreaking approach to disaster recovery, combining advanced technologies to save lives more efficiently. And moving towards the next slide, we have these research papers and references that we have referred for our proposed solution. And thank you for your time, and we look forward to your feedback. Thank you.